In this video, I will be explaining some of the problems that are very important for calculus and variation of integral equations paper in second M.Sc mathematics. Okay. So this is the problem I will explain. In this note, it is not proper. Okay. So what I did is I analyzed it and I wrote it on another paper based on my understanding. So here what I'm going to do is I will explain you this problem, okay, in a very simple manner. Okay, here my notes looks very beautiful and easy when you compare it with the notes I got from the college. Okay, that's not proper. It's a seminar portion, so not everyone gives us good notes, right? So here from this, using this as my reference, I wrote on some other paper with proper steps, and my notes looks very easy to you. Okay, let me start. So here let's read the question. So what they are doing is they are giving you a differential equation and they are saying y of 0 equal to 1, y dash of 0 equal to 0. What they are saying is you have to transform this differential equation into integral equation like this. Okay, you have to transform this differential equation into integral equation. And in the second, okay, when we learn the second part, I will read you the second part question. Okay, so first let us prove this first part. Okay, it's very easy actually. First you have to write the given differential equation. Is that clear? Now this differential equation can be written like this, right? You can write d square y by dx square like this, right? D by dx of dy by dx. You can write this like this. Okay, plus write the remaining as it is. And in the next step what you are doing is d by dx of this, in the place of dy by dx you can put y dash of x. Okay, dy by dx can be written like this, plus lambda y can be written y of x. You are writing with x, okay, in all the terms. Okay, now what you are doing is in the place of x you are going to put x1. Put x equal to x1. So when you put x equal to x1 you will get like this. Okay, and now you have to integrate this over 0 comma x with the interval 0 comma x. You have to integrate this so that you get this steps, integral 0 to x, this step, okay, plus lambda integral 0 to x, this. You are differentiating this with respect to dx1, so you are putting dx1 at the end. Okay, now you are integrating this. When you integrate this, here integration and differentiation are nearby, right? So both will get cancelled and you get the remaining value y dash of x1 and the limits 0 to x. You will get like that. That is how you have to integrate this one. Plus lambda 0 to x, write the remaining as it is. And in the next line, you are applying limit y dash of x minus y dash of 0 you will get, and remaining terms as it is. And then in the place of y dash of 0 you are substituting 0. The reason is because in the question they are given you y of 0 equal to 1. So when you find y dash of 0, when you differentiate this you get 0, right? So substitute the value of 0 here so that in the next step you get this. Now what you are doing is you are putting x is equal to x2 in this equation. Okay, so that you will get this. Okay, and now you are integrating this over 0 comma x with respect to x2, so that you will get this. You are differentiating with respect to x2, so at the end you are putting dx2 and all. And here I hope you understand. Okay, everything will be here. First you have to put this integral. Okay, for this term what you are doing is first put lambda and then put this integral. Okay, the integral that we are taking, that integral, and then the integral already there in that term. Okay, y of x1 dx2 is equal to, similarly do this. Okay, now integrate this so that you get here integration and differentiation are nearby. y dash means there is a d by dx of this, right? So differentiation and integration are nearby, so both get cancelled and you get y of x2, and then apply the limit. Plus here in put lambda as it is, and for this you are applying a theorem that you will learn just before this problem. Okay, if it is like this, you can write like this, that is I will tell you 1 by this 2 is this integral's suffix 2 minus 1 factorial integral 0 to x minus epsilon, this 2 minus 1, here this y of something, right? So you put y of epsilon d epsilon. You can write in this format by the previous theorem. I will show you the theorem if it is necessary. It is necessary, okay? That's a very important theorem. I will upload that video also later. So here, this is the theorem, okay? If it is like that, then you can write like this. How? Put 1 by n minus 1 factorial. It means n minus 1 factorial. Okay, you can write like this. Okay, here you have n number of terms, so 1 by dxn till dxn you have, right? So 1 by n minus 1 factorial integral a to x. A to x means here you have x. Where? Okay, they have written in this format, okay? You can understand when you look at that and understand it by your own, okay? You are writing this in that theorem's format. Also, this is also you are writing in that theorem's format. Then you are applying limit plus lambda. From this you will get this, and from this you will get this. Okay, and then what you are doing is you are taking minus from this, minus common outside, so that you will get like this, minus x plus epsilon, and this can be written, you are taking minus outside, right? So that here is minus, and then this becomes minus x plus epsilon, so you can write this as epsilon minus x. Is that clear? So I already have minus here. Sorry. What you are doing is here you are bringing, in the place of y of 0 you are putting 1, because here in the question they are given. And now what you are doing is keep y of x in the left side and all other terms bring it to the right hand side, so that you get this, and from this you are taking minus common from this term, so that you will get so that the minus one minus, this minus and this minus together get cancelled, and you will get this term. Okay, here also you are taking minus common, so that this becomes minus. Okay, and let us pass on to the finally have proved it. From the differential equation you brought the integral equation. Okay, is that clear? Nothing is here to feel difficult. Now the second part of the question is, you have to say the converse of the above statement is always true. Okay, that you have to do it in a reverse manner. So in the last part you got this as your answer, right? So in the next part you are taking this, okay, let y of x equal to this value, like that you are taking, let y of x equal to this. Okay, now from this you are finding y of 0, so that you will get this. So from this you can get y of 0 equal to 1, because here integral 0 to 0, integral 0 to 0, this becomes cancelled. Okay, this becomes 0, so that you will get only 1 here. So y of 0 equal to 1. Now you are finding y dash of x, you get this. When you differentiate y of x, you will get this. And when you find y dash of 0, in the place of x you are substituting 0, so that you will get this. Now you are differentiating what? Y dash of x with respect to x. Then only you can bring the in the differential equation that is given in your question. Okay, to bring that you are differentiating this with respect to x, so that you will get this. Here differentiation and integration are nearby, so they both get cancelled, so that the next step you will get this, and from this you can get this. Finally you are writing everything that you got in this part. Okay, so that is how this problem comes to an end.